Hey everyone, this is my video lecture for chapter 3. I'll try to go a little bit slower this time, give you a little more information. You're not going to see much of me on these because the microphone is actually behind the camera. Kind of a crazy setup, so I'll be back there talking to you. So chapter 3. This is looking at Earth and space and solar energy. I bet a lot of you were surprised that there's going to be so much stuff involving the solar system and the galaxy and the universe in this chapter. But, we start out with the big picture as we get into finer and finer detail as we move forward. And as you'll notice, some photos that I put in these lectures are from our textbook, and some are from other sources that I find, and of course you'll only ever be tested on anything from our textbook. Alright? So, galaxy. This is a picture of a galaxy here. This one is actually similar to our galaxy. It's a spiral galaxy, as you can see, a little spiral there. In a nutshell, galaxy is a really, really big place. Yeah, that's a good nutshell. Looking at representations of the Earth compared to the Sun. Our sun is quite a bit larger than Earth, but there are many, many other suns as you look in here. The one that looks like it might be pronounced Betelgeuse is Betelgeuse, which you've probably heard from before. Antares there, another very large star compared to our little sun if you look in these graphic representations here. Some other planets there as well, Jupiter, Saturn, etc. So, solar system. Our solar system is all the bodies that are going around our sun. So, Earth, other planets that you see on the list here. That's all the stuff that's going around our sun is our solar system. Solar meaning sun, right? Makes sense? Closest other system to us is actually a triple star system called the Centauri system. Alpha Centauri, Beta Centauri, and Proxima Centauri. Alpha Centauri is a little bit larger than our sun. Beta Centauri is a little bit smaller. Proxima is a lot smaller. And if you're going at the speed of light, it would take over 4 years to get there. So, again, space is vast. Here's a bunch of other moons and objects that are in our solar system I thought you might find of interest. I'm not going to quiz you on all this stuff there. So there's a comet. Comet has two tails. Ask the question why there. Well, it has two tails because one is being created from in a nutshell, the path that the comet's traveling, right, it will be leaving behind a trail behind it that way, but then it has another stream from our solar wind hitting it and having a secondary ionized stream going off that other way. So that's why it would have two tails. Alright. There's a large big impact crater there as well. I believe that's in Arizona. And I believe I got that out of your book, so you could read more about that there. So all stars are self-luminous spheres of gases that emit radiant energy. So when you talk about solar power, all stars out there give solar power. That's why you're able to see them, right? Because they're emitting that light that you could see. Let's see, that's good for there. So when I talked about the comet having two tails from the solar wind, that's ionized gases that are leaving the sun. Our magnetic field blocks this. Sometimes the solar wind is funneled down into areas such as the far north and south poles. I'm not sure if any of you have ever seen, the northern lights, Aurora Borealis, but it's really something to see if you ever get a chance. I actually saw some in northern Minnesota, though it's rare for it to come that far down from the. Let's see here, sunspot there to the right. There are cooler regions that have 11-year cycle. Its latest sun spot cycle is taking a bit longer than normal. And there's a little insect picture of the Earth to compare the size. So in a nutshell, when you're looking at planets in our solar system, you have two groups. You have terrestrial planets that basically are rocky, hard planets that you could stand on. And then you have gas planets or gas giants, such as Jupiter, Saturn, Uranus, Neptune, that are mostly made out of hydrogen, helium. They're gas giants, so mostly gas. Yeah. So check out those statistics there and see what you think. So this is a photo from Mars, and a lot of geography uses satellite imagery. So it's always interesting to compare because there are always these photos from Mars in the news. And if you look at these little markings, you would think, well, hey, that might indicate that there was liquid water present. But as you'll find out as we read later, very similar markings could be made from just the Earth moving and sand moving through time, through large amounts of time. So these things can be misleading. And there's a little insect there at the top showing, some scientists have talked about what if water used to flow on Mars? So that's what it would have looked like hypothetically. So energy from the sun is in the form of electromagnetic energy. All right, electromagnetic energy. Solar radiation is shortwave radiation, whereas terrestrial Earth radiation is long wavelengths. What does that mean? Well, all right, so wavelengths. Picture. All right, so you got wavelengths that are short, right? Short. They're coming down and they're hitting the Earth, and when they hit the Earth and they bounce back off, after hitting the Earth, they're a long wave. They've been bounced into being a long wave. So when we talk about this energy coming from the Earth, well, it's coming from the sun originally. It's just bouncing off. And this is a similar effect that happens when, say, you have a car that's out in the sun. You'll have that long wave energy coming through your windshield, and much like our atmosphere, your windshield, shortwave solar radiation could go through it really easily. And then when it's bounced back, that long wave, that's actually blocked from leaving your car. So it just kind of bounces around inside your car and makes it heat up. And that's one of the reasons why our Earth is nice and warm, right? Otherwise it'd be very, very cold. You could read the rest there. So when we're talking about the movement of the Earth, you have galactic movement. So I talked about our solar system already. Inside of our galaxy, the Milky Way, there's many, 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 many solar systems. And the galaxy itself is slowly rotating, so we're moving within the galaxy in that way. The Earth itself is also spinning on its axis, and it's also going around the sun. Right? So, globe spinning on its axis, right? And this is the tilt, the axis. This is why we have seasons, because when the sun's hitting it directly, nice and warm. When it's on the other side of the sun, right, and the sun's hitting this part directly, and this part's getting much less sun, right, well, that's when we get our winter. And there's a quiz question about this. Do not make the mistake in saying that we have summer because the Earth is closer to the sun, because during our summer, the Earth is actually further away from the sun. It's all about the tilt, all right? So you read more about that there. Oh, so in a nutshell, rotation is that spin, and revolution is going around the sun, takes a year. Excuse me. Well, you can read about this stuff here. A little bit more about seasons and why they happen. So if you look at here, sun's vertical rays, right, those are direct, they're hot. Sun's oblique rays, see how that same amount of sunlight is spread over a large amount of Earth's surface, and so that's why it's cooler in those parts of the world. And one of the reasons why on average it's much warmer around the equator than it is around the poles in general. I'm going to run out of time here. I'll read about the tropics, Antarctica. Let me cut it off there. That was a good summary. I'll see you all in the discussion section.